Alright, so today I wanted to show you guys a little bit on how I process my data. I've been pushing some videos out on how I set up my rig and capture images and all that. Let me show you a little bit behind the curtain, if you will, on how I process the data. So most recently I've imaged the Fishhead Nebula, and so I'll show you how I got that. You'll notice I'm using Pixinsight 1.8.6. I've upgraded to this from Photoshop earlier this year, I think in January or February. It was one of the greatest upgrades of my astrophotography I've ever done. I highly recommend Pixinsight. So I'm going to just start by showing you how I do it, how we open a file. You can go to File and Open, or you can just double click the background. So Fishhead, okay, so here's my HA. There it is. And oxygen, and sulfur. Alright, so before you start combining these channels, it's often a good idea to process them individually, and I've kind of got them to the point where I want them. So you gotta watch out for gradients due to light pollution and what. So when they're black and white like this, or monochrome, it's a lot harder to tell what is real signal and what is a light pollution. Over here you can see some faint nebulosity. Of course the fish head itself is pretty obvious with some other stuff up here. But you want to be careful to not clip your darks. It's pretty dark over here. I wouldn't go darker than that. I think some of this over here is a light pollution, but we could deal with that later. Over here, the sulfur channel, I could probably do a little better in clipping or reducing the background, so I'll open up my Histogram Stretch. You want to make sure the border is blue. You've selected the one you want to work on. Hit this check mark to show what the current histogram is. Hit this circle button to show a live preview, real-time preview. So I'll just come over here and move that in a little bit. Something like right there looks good to me. Close the preview, drag and drop onto the correct panel. And it's often good to look at the before and after, so I'll come over here and undo and redo. There we go. Nicely cleaned up that background. And I think the oxygen is fine. It's a pretty weak signal. I probably should have exposed for a little bit longer. Oh well, let's see what we got here. So I'll go ahead and save this. Overwrite that. Alright, so now that we're happy with our S203 and HA, we can go ahead and co-register them. So we open up star alignment. But before we do that, it's a little bit easier to do all of this if you have, hold on, if you put them all in a common folder. So I will say align. It's a little tedious, but it'll save us some trouble later. Alright, so we want to go to View, File, and hit this little down triangle to load our reference image. I usually use hydrogen always as my reference image because it's the strongest signal typically. We can add, now we're going to add all of them, including the hydrogen again. It knows how to handle that. We'll skip the format hints. Output directory we'll choose as the align folder. And then you could play with these settings. I've found that bumping these first 4 up by 1 works pretty well on pretty much all of my images. I moved the ransack tolerance to 3.4 and I changed the iterations to 4,000, and the descriptors per star I changed to 60. Then I hit the circle button, which is apply global. So you let this run, it just takes a moment. You could also generate drizzle data, but I'm not gonna talk about that in this video, maybe some other video. So I'll let this run. I'll get back to you when it's finished. Alright, so that finished. We could check to see that it's done its job by going into the folder, and you'll see that all of those 3 files have been duplicated with an _R. This means that they've been registered. The R is for registered, meaning all the stars between these 3 line up with each other. So we can close this and all 3 of these. Yes. And now we want to open the ones with the _R. So we'll go to align and just grab these. And you'll see this like dark border here. That's where the image has been shifted to align with the others. So we're going to just hit this little arrow here to minimize them. S, H, and O. We're going to open up one of my favorite modules in here, Pixel Math. This thing is one of the most powerful modules in all of Pixinsight. I use it all the time, especially with narrowband. So we're going to say create new image. I'm going to call this SHO test to distinguish it from the other ones. Alright, so up here in your R, G, and B channels, ignore the A for now. We're going to type in the exact file name, which can be seen right here. So we're going to do S2 _R, HA _R, and last but not least, O3 _R. And now you want to make sure under color space you go to RGB, otherwise you're not going to get an image. Then you're just going to hit this square to execute, and there you go. We'll get rid of that. We could even get rid of these now. Now this image is green, so we're going to take care of this greenness. That's all the hydrogen. Remember RGB, SHO. So we're gonna deal with this really easily. Alright, so the way we deal with this is another one of my favorite modules called SCNR, Selective Color Noise Reduction. We're going to make sure we select the green channel, and you can change the amount. This is like 100% and 0% and whatnot. I like to go full 100%. You could leave a little green in there. Here, let me just show you. Like if I do 30%, see, it barely removed any of the green, but it removed some of it. If we go to 100% or 1.00, there you go. Now we got this nice gold and blue colors that's typical of the Hubble palette. But before we go any further, I want to trim these edges. That's from co-registering the 3 channels. So we're going to go to decrop, dynamic crop, and just sort of move these edges in. Now notice that little square that my mouse has turned into. See how there's like a little tab that appears on the top? That means we could drag that edge down. Same for the side, the right side, the left side, and of course the bottom. If you have it on the edge but that tab isn't there, like if it's like this, you're not going to be able to drag it. It just moves the whole thing over. So I want to trim the edges, so we'll put that there. You don't want to lose too much, but you don't want any artifacts remaining. Move that one like right here, and just hit this green arrow, or sorry, green check mark, and you can see it's trimmed it nice and clean now. Okay, and it gives you the new dimensions, 4482 by 3370 pixels. You can get rid of that now. Alright, so the next thing I like to do, you see this graininess, that noise? Let's clean that up. I'm going to select a preview so I could zoom in. I just grab this area over here and a preview pops up over here. So now that's just, we selected a portion of the image. I'm going to go to Denoise, or multi-scale linear transform. There's a lot of denoising modules that do different things that you can learn about. And then I'm going to add the layers to 5. And what I like to do is add a threshold of 3 layer with 1 iteration. And then going down, I like to reduce the threshold to sort of chew away, to eat away, chip away at the noise. And I'll go down to 1. And let's just hit this preview box right here. So that's going to run. The smaller the preview, the quicker it generates a preview. So here we go. And we can say, is that better or worse? We could hit this button here. Before, see all the green? After. We might have overdone it. So I'm going to step this one down. I'm going to reduce the threshold. Actually, I'm going to get rid of this one. Let's just do 2 and 1. It's going to update that. You don't want to be too aggressive. That's pretty good. I think I'm going to take this one. You can change the amount. Let's take that down to like 0.7. And there's just a tiny bit left, so I'm going to add in a really small 0.05 or 0.5 and go the amount of 0.7. Alright, that looks pretty good. Before, after. Alright, so I'm going to get rid of my handy dandy preview, go back to full screen, and just drag and drop. Let that run. Just takes a minute. Alright, it's already done. So let's zoom in and do a before and after so we could see how well it works. Hit this back arrow. See the grain, and now smoother and cleaner. Now you don't want to try to get rid of all the noise. It's not really possible anyway. But you want to think about it as noise reduction. You just want to chip away at it so you have a little bit of a cleaner image. Alright. And also there's this bias thing. I didn't use it here. But if you add just a tiny bit of offset, like a 0.05 or 0.08, maybe a 0.1, it tends to try to sharpen. But we're going to use different modules today for sharpening. So let's go ahead and move on. Alright, so the next thing I want to do is try to clean up the background a bit. Let's take a look at the histogram. Alright. So hit this check mark and you'll see the green, red, and blue channels look vastly different. And that's okay. I want to hit the real-time preview button. And you can click around and it'll show you on the over here with some colored lines what the values are of that pixel at that location. So I think everything is relatively okay. What I want to do instead is do an ABE, this automatic background extractor. It's going to model the background, try to figure out what is noise, like what is light pollution, and what's actual signal, and then remove it. So all you do is you come down here, for correction, go to subtraction, discard background model, and I like to do replace target image. We could always back it up if we don't want to do that. Alright, so you'll see some green popping up around the corners. It thought it cleaned up this area. That actually looks legit. So here's what I'm going to do. For now, I'm going to just minimize that. And I'm going to use this really cool thing that I've called, that's called color saturation. And if you click over here, you find the green, you click where it's green, there you go. We could run an SCNR, but let's see what this does first. Let's go to the green part and just see this horizontal line. That's neutral, or no action. Above it is to amplify a color. Below it is to remove. So I want to remove some of this green. And you just click points along that line to zero out the other colors that you want to preserve, or to make them unchanged. And then let's hit that preview. Hey, that looks pretty good. You could drag it further down to remove more. That looks pretty good. Let's do before and after. Before, after. Watch this area down here. Before, after. Alright, let's... So here's what we could do. Whenever you're undecided about which path to take, what I like to do is, here, let's undo that. Back up. I could clone the image by dragging that tab and dropping. It's real handy. And I'm going to take two paths. On the left one, I'm going to use color saturation to remove the green. I don't think it got all of it, though. And on the other one, I'm going to run the SCNR, 100%. So yeah, I think I like the right one better. I think it got more of the green. See, trying to get them on the same screen. I like this one better. I think it's modeled the background better and got more of the green. So I'm gonna actually remove that, undo this one, go back to the way it was, and then run that SCNR. And we'll be off to the races here in a moment with some of the more fancy stuff that we're going to be doing. Alright, so now what I want to do is sharpen this image up by running a deconvolution. So by the way, all of these tabs here, those are just the most common, those are the ones I use most frequently. They come from the process. Look at all of these. These are all, this isn't even everything. This is just, these are just the main processes. There's also a bunch of scripts you can run. So there's just so much here, and you got to sort of go through them as you need them. You don't really have to learn them like reading a book front to back, cover to cover, but these are the ones, and you could give them names that make sense to you. So I've just saved them over here. If you highlight them and then say save selected icons, then when you start up Pixinsight, you can right click and go to load process icons, and they'll just pop up right here. Anyway, so the first thing you want to do for a deconvolution is run a dynamic PSF. So PSF is a point spread function. It's essentially the mathematical equation that quantifies how a point source of light, such as a star, is blurred out or spread out by atmospheric distortion and refraction. And the amount by which that point source has been spread out can be quantified, modeled, and then subtracted, if you will, removed is more accurate, by what's called a deconvolution. But first we have to tell this program what the typical star looks like, how each star, or not each star, but how the stars have been typically blurred by the atmosphere. So you have to click on a whole bunch of stars. The more the better, really. I usually do like 100 or so. And you want them to be spread out among the whole frame, like some all the way up in the corner, along the edges, in the middle. So I'll do this and I'll get back to you. Hang on. Alright, so here is the result. I've clicked on all these stars, and I made sure to not get the really bright ones. Like this one is way too bright. It says I have 350 stars, and you want this A, which is the amplitude, to be between like 0.7 and 0.92 or something like that. So I have a whole bunch of, some of them are a bit large and bright, but some of them are too dim, but I don't really worry too much about that. And another thing is, typically you do this deconvolution when your data is in the linear state, like before you've done any stretching. That's a big point here to keep in mind, but I don't know. I've had pretty good results doing the deconvolution after I've stretched the data. You can play around with it. So anyway, once you've clicked on a bunch of stars spread out throughout your image, see this little camera icon? Just click that, and there you go. If you zoom in, you see the star. It's relatively round, actually. I'm pretty pleased with that. But what it's done is it's generated a synthetic star, a composite based on all of these. That's sort of like representative of your entire image. If you want to save that, not save it, you just want to minimize it and save it off over here, let it chill over there. Hit that red X to exit out of there. Alright, next thing, and that's the hardest part. It's the most tedious part of the deconvolution, but it's worth the effort. Come over here to see these two like rainbow colored icons, sort of like when you're playing Mario Kart and you're getting you pass through something that looks like this, and it gives you a weapon or a little like a package to use. You get the shell or whatever. It looks like that to me, only it's rotated. Hit the one on the left to extract the luminance channel. And so it spits out a black and white image, which is luminance. That's just like all the nebulosity. You're going to drag this tab and just drop it right here on that border. And minimize this and put it up here with the PSF. Do not close this, or else you'll exit out of it. It's like, whoa, everything turned red. What in the world? So we just made a mask. Notice that the tab over here turned brownish red. So what we're going to do is come over here and hit Show Mask, Control K. Now it's still there, and we know that because this is brown, but it's just getting rid of all that red so you don't, get blinded. I can also hit Control K, on, off, on, off. And I can also invert it. So watch this. If I hit Control Shift I, it inverts it. We want it in this default state, and we're just going to not display it. Alright, next thing we want to do is make a mask. And I like to bump up the noise threshold a bit and the small scale threshold. And you just drag and drop this and let it generate a star mask for us. This just takes a moment. So what we're going to do here is use the mask of the stars, the synthetic star, and the luminance mask in order to run our deconvolution. We haven't even done the decon yet. These are our support files. Alright, and there it is. And something weird is going on over here. So we're going to retry that. I'm going to take the scale down, move this up, try this again. Alright, so I forgot to remove the mask. You don't want to make a star mask when your luminance is on there, so I removed it, generated a mask. It didn't all go away, though. It's still doing this weird grid thing, but we're gonna just proceed forward. It's not probably shouldn't mess anything up, although I will say I've never seen this before, so I'm sort of going with the flow here, and that's really part of the craft, you know, just going with the flow, trying new things out. So we'll put that luminance back on. Now we could open Deconvolution. At the top under PSF, let's go to external PSF, load the PSF we generated. Under algorithm, you're gonna just stick to regularized Richardson-Lucy. D-ringing, we're gonna make sure we go to local support and add our star mask. In iterations, here's where the magic happens. The more, the better, although without overdoing it. I usually, on stretch data, I like to try something between 15 and maybe 30, but if you run this now, it's going to take forever. So we're going to make a couple preview boxes here, real small ones, on some interesting areas of nebulosity. Alright, how about in here? And don't worry about the noise, we're going to deal with that. So let's run this on here, see what happens. It's an iterative process. Alright, so you'll see some changes in here. So we're going to right click here and reset. See, now that's done. Let's see if this gets better. That's pretty good. Let's bump this up to like 22 and reset. Right click, reset, run it again. Yeah, that's pretty good. Look at that detail in here. And make sure this is reset. Try it on this one. And you just gotta play with this until you really get it to a level that's good. You don't want to overdo it. You don't want to get this like worminess. I'm gonna bump it down a little. Let's try 19. The de-ringing is important. I don't, in this case, I don't have a need for it, but you'll get these annoying like dark rings around the stars that really ruin the whole image in a way. So you really got to be careful. So it doesn't look like I'm going to need to use it here, but just keep in mind what you would do is just add a slight amount of global dark, rerun for that iteration level, and then keep increasing global dark until the dark rings are gone. But it looks like we don't need it here. So I'm going to go ahead and run this on the whole image. It's going to take a little while, so I'm going to pause the video and get back to you in a moment. Alright, it finished. So here's what I came up with. Let's zoom in a bit and let's see the before and after. Alright, so here's before, after. Yes, definitely crisped it up a bit. See that? It's really subtle, but it makes a difference. You don't want to try to go at it with a sledgehammer. It's all about chipping away at noise, you know, slowly bringing out the details. You want to be real subtle and cautious. So I've noticed that I have a bunch of noise in the background. Now that's to be expected. First of all, I'm going to minimize this because sometimes I might try to come back to it and work on it some more. And we'll just remove the mask. Alright, so with low signal areas, the noise is more pronounced because when you think about it in terms of S and R, or signal to noise ratio, if your signal is low and you have, let's say, the same noise throughout the image, then the noise will be more pronounced in low signal regions. But I don't want to denoise the fish head itself anymore, because then we're going to start chipping away at the fine detail. So what I'm going to do is use what's called a range selection to create a mask. Let's hit the real-time preview. So we have the lower limit at 0, upper limit at 1. We're going to bring this in until we have, also I want to bring the smoothness way up. I'm going to bring this upper limit down. Watch what happens. So it's grabbing that fish head And then if you bring it all the way down, it just becomes black. We're going to go to the point where just the fish head is selected. Right there. Alright, we're going to close the preview and hit this main image with that. So we're going to just normalize the frame, minimize this, put it over here, grab this tab, drop it onto the border, minimize, don't close, put it over here. Now let's hit Control K. See that? So the red is protected. Actually, it's a little bit red up here, which is what we don't want. So I might have to go back. So yeah, let's do that. We're trying to denoise this region. So we're going to remove the mask. Get rid of that. Open up our range selection. Look at the preview. And bring this down a little more. There. It's really just these high signal regions that we're interested in protecting. This stuff over here is okay if it's not all the way protected. Drag and drop. Alright, this looks better. It's still a little red over here, but I think we'll be alright. So I'm going to hit a Control K just to not display what's being masked. Come over here to denoise. Let's make a preview in some of this noisy area. Go to that preview, and we're going to go layers 5. It's just something I do. Noise reduction 3, and hit the preview. We might do more layers, but let's see what this gets us. Alright, before, after, before, after. That looks pretty good. Remember, we're zoomed way in, so you don't need to, again, you don't need to hit it over the head with a sledgehammer. Get rid of that preview and apply it to the whole thing. Should take a minute. And, oh, it's done. Alright, yeah, because I was only doing one layer. Cool. So you can tell a big difference now. It's a lot smoother in here, and we've preserved the detail in the high signal area. I'm going to remove the mask. Get rid of this window. Get rid of the mask. Yeah, it's okay. Get rid of this. Alright, so now what I want to do is a curves adjustment. This is where it's going to get really fun. Check this out. We're going to click this button over here with the S. It's called saturation. We're going to hit that trusty real-time preview again, see what we're doing. Now I want to make an S curve or just watch. See that color coming in? Let's bring in some of this. Look at that. See, it's getting... Alright, actually, before I do this, watch. Let's get rid of this. There's something I want to do first. And I wish I hadn't closed that range selection. I think it remembers, though. Watch. Yeah, those are the values I had selected previously. So we're just going to drag and drop that. We want our trusty range mask. Drag and drop. Alright. So, right, go back to the curve. Let's see what the mask is doing. Alright, now we want to hit Control-Shift-I to invert it. And you could also go to mask and hit invert mask to switch between protecting the background or the other way around. But I'm going to hit a Control-K to get rid of it, just so that it's not displayed. Go back to our curves, S, preview. Now let's bring this up. So you can do multiple curves. There we go. Let's bring out that blue. Yeah. Go back to the saturation. Yeah, it's good for now. Close the preview. Watch this. Drab to vibrant. See that? Boom. Let's just reset those and get rid of this. Alright, so we're almost done. The color looks good. We could play with it a little more. One last thing I want to do is let's go to the lightness. I want to brighten up this area. See, if you go like this, it's way too bright, way too dark. So what I want to do... Actually, let's get rid of that mask first. Let's brighten up that interior. You don't want to blow it out though. There's a lot of really tenuous detail in there. And then we'll hit it with some more saturation. That looks good. Let's apply that. Yeah, there we go. It's really starting to come out. So now I want to do one of the last things, which is the unsharp mask. Funny name for something that sharpens. I'm going to... Oh, hold on. I'm going to grab a portion of this, which is the interesting part, and I want to work on this. I took a moment to dig a little deeper into the situation, and I found what's going on. So here's the Fishhead Nebula as it has been most recently. Turns out these are the values that I need to use for the star mask. So it's going to generate a nice clean star mask. Let's let that run, and then we'll get back to the unsharp mask, because the unsharp mask is really best for sharpening in my view, because it has the de-ringing module embedded within it, so you can make sure you're sharpening your nebula without producing weird, wacky stars. The stars really are, they can really distract the image if your nebula is great and your stars are all weird. So here you go. Here's the stars. We're going to apply that mask. Minimize that. Minimize that. Now watch this. I've also found these values for the unsharp mask to be best. Let's do a preview. Oh, whoops, hold on. So we want to show mask, we want to invert it. There we go. See how the stars are red? The big ones I didn't capture because you see over here, if I wanted to grab the big stars, I could increase the large scale, but it's okay. We don't need to worry about that. So we want to make sure it's inverted and in this form. We're going to not show that mask, and now we're going to hit this. There we go. Before, after. So it made some of the stars pop out more, but that's okay. We could deal with that. But look at the nebula. It's a lot more detailed. See that? So over here on the de-ringing, which I have that box checked. The dark, that's to get rid of any, that, like I was talking about, the raccoon eyes, the little dark rings around it, which you can really only see unless you're zoomed way in, unless they're really bad. And so for the bright, it makes them just not as bright. See this? Watch. So we can also erode, we can run one of those star erosion algorithms as well. I'm going to go ahead and bump this up a little bit. I see a little bit of dark circles around that star. See, now they're also getting a little bit fuzzy. See that? You don't want that either. So I'm going to bring the bright down a little bit. see here. Okay, I might have overdone the, whoops, somewhat paradoxically, the dark. If you overdo the dark, see, there we go, yeah. Okay. There we go. So we don't have any fuzzy halos popping up around the stars, and the nebulosity is just fantastic. I'm going to try 0.09. Okay. Alright, great. So let's run that on the main image. Boom. Alright, so we don't want the stars to be too prevalent. They can really distract from the image. What's this? Oh yeah, don't look at that yet. So we want to come over here and go to this reduced stars. It's the morphological transformation. We're going to invert the mask, the star mask. See that? This is what it was before. Now we're going to, whoops, hold on, I just inverted the whole color space. Control Shift I, there we go, and now Control K to get rid of that. We're going to run the star erosion at like 0.29. Alright, here it is. Here's the before, after. Before, after. Yeah, we can run it a little more. If you just run it again, we could see what it does. There's also an iteration, I think. Yeah, iterations. Okay, see, the stars are a lot more muted now. They're not like so distracting and bright, and I mean, they're like embedded in the nebula, and you don't want them to be too overbearing. So I might have overdone it a tad. Let's bring this down and run it for the second time at a reduced magnitude. There you go. That looks pretty good. So the last thing I like to do is just a quick saturation, just to make sure everything is optimized. I'm going to remove the mask. Let's see what we got here. Yeah. You don't want to overdo it though. You got to find that nice balance. See if we could add some dynamic range here. That looks pretty good. Brighten up this region here a little bit, but not too much. See if it's down more. Yeah, let's bring that up to right there. There we go. Alright, and now let's run that. Alright, so this is pretty close to the way I've processed it originally before I've made this video. I will show you quickly how to clean up some of these color artifacts. If you come over here, you click, so it's magenta over here, it's a little bit blue over here, so we can just click in those color regions and then click everywhere else that we want to preserve. Alright, and then just drag it down to negate it. Now be careful because they'll sometimes pop up over here, and you don't want that. So I've gotten rid of the blue. I kind of missed the peak. Let's bring it over. Oh, but you know what? I'm attacking this region, which we don't want to do. So let's grab our trusty range selection. Let that run. There it is. So we're going to just use this range mask to protect the fish head and attack the background. Let's check to make sure. Yeah. Alright. So grab this. Before, after. Hey, that looks pretty good. Those colors have been selected out. Now the background of space is nice and dark. So when I click here, see, there's a line that pops, the crosshair pops up here, and it's right there at the peak, or at the trough rather. There we go. So we'll run that. And there you go, nice and cleaned up. Remove the mask, get rid of that. So now I'm going to show you, whoops, uh-oh. How do I get out of here? This? There. Alright, so this is what we've just done on this walkthrough. This is what I've done earlier. Okay, so it's a little bit more saturated with the colors, but it's got the same detail. We could actually do a quick saturation adjustment. This is actually one of the easier things to do. And so we can actually have that up so we could compare them in real time. It's not going to be exact. That's pretty close. Alright. Alright, so we got them more or less equalized. But the point is that if you're never gonna be able to do an entire image processing from beginning to end from memory and get it exactly the same. These are pretty close. But certainly you've now seen all the details from beginning to end, all the things we've learned, the deconvolution and making range masks and star masks and luminance masks and inverting them. All this stuff is important. I just wanted to show you guys that's some of the power of Pixinsight. It does a lot of stuff that you just cannot do in Photoshop. Just doesn't exist. Because Pixinsight was created specifically for this purpose, whereas Photoshop is for regular, like terrestrial photography, which is great, but there's a lot of features in Pixinsight that are just invaluable that you cannot get in Photoshop. Anyway, here's the final image that I've posted already, so I'll close with this. Let me know if you have any question, guys. Please subscribe. And thank you so much for watching. Clear skies.